Alright, welcome to another lecture here looking at bank tracks, and this one's a little bit interesting. It all comes down to, when you do these problems, of getting a picture of what's going on with the question. So let's have a look at this one. A train travels at a constant speed around a curve, radius 450 meters, and a lamp on a cord hung from the ceiling swings to 12 degrees during the turn. So that's implying that the train is turning on an angle on a banked track, and as it does so, something that's freely hanging from the ceiling moves, right? So if we just draw a diagram like this, here's our train. And if something's hanging from the ceiling, you want to draw it like this. But then you've got to remember that there is being acted upon by gravity, so it's going to swing down straight. Okay, so let's add that in there. And we're going to say that's hanging down like that. That degrees there is 12 degrees. And if you remember from our diagrams before, the angle up here, because this is the centripetal force going this way. All right. And we remember we had the normal force of the train going up like that, and we had the components of the normal force going up this way. So that was F and Y, and that was F and X. And if you remember that our triangle here, when we drew it before, the angle theta here in this case, which is 12 degrees, equals this angle here. And that angle was the same up here. So this angle here is theta is 12 degrees. So the track is banked at 12 degrees. That's what it's saying there. So let's have a look. We've got a radius of 450. We've got the banking angle there. So now we have to remember that our equation v squared, right? V squared is equal to Rg tan theta. So we put in the values and see what we get. So it's 30.6 meters per second, but then of course we want to convert it to kilometers per hour. So then we times that by 3.6, and that gives us 110.2 kilometers per hour. So that is the speed of the train. So that's a quick and easy question. Let's do another one, I think, because this one here, though, they told you it was just deciphering the information, getting the angle out, and then remembering the formula and plugging it in. Let's do another one to see if we can utilize this equation here to find out what an angle is. All right, let's do this one. So if a car travels at 28 meters per second, what is the minimum angle that the road should be banked at so that the car can safely take the turn? And the radius of curvature is 600 meters here. So we're giving a banked turn. We don't know what theta is. And then we have our car here. And we know that its velocity is 28.0 meters per second. And the radius of curvature of that is 600 meters. So let's look at our equation. Remember, so the equation was v squared is equal to Rg tan theta. And therefore tan theta is equal to v squared divided by Rg. And therefore theta is equal to the inverse tan v squared on Rg. So let's plug those values in and see what we get. So we have velocity, we said was 28, square that, over the radius, which was 600 meters, g 9.8. And of course you have to take the inverse tan of that, so you've got to, don't forget that. Yeah. All right. So when we do that, we should get 7.59 degrees. So that is just, once again, remembering this equation, making tan theta the subject of the equation and substituting some values in. So fairly straightforward once you remember this equation here. Okay. And once again, you could derive that equation if you wanted to, if you can't remember it like we have in the previous video. So that's banked tracks number 2, and hopefully you're getting the hang of it now. Okay, we might just do one more just for good measure. Alright, here's our last problem. An aeroplane is flying in a circle at a speed of 550 kilometers per hour with wings tilted 45 degrees from the horizontal, and there's a lift force provided to the wings that's perpendicular to it. So let's see if we can draw a picture here. So here's our plane. Alright, imagine the plane's coming towards you. And with that plane there, if we were to draw it in, that would be 45 degrees. It's tilted 45 degrees. And so therefore, for that plane, it's going to have FC, centripetal force, because it's going in a circle. And on our other diagrams, we've drawn a normal force, right? In this instance, we're told here to lift force. It's provided perpendicular. So that is the lift force provided perpendicular. And so the same concepts here is that lift force can have a vertical component and a horizontal component. That vertical component, the lift force, the vertical component of the lift force is equal and opposite to the gravitational force that's coming down here, the mg. Since the plane is not going up, it's not going down, it's just going around in a horizontal circle, right? So the question is, what's the question? Well, here's the question. What is the radius of the circle? Okay, so we've had questions that look at velocity, we've had questions that look at the angle, now here's a question to do the radius of curvature of the circle, of the turn of the bank. So here's the same sort of thing. If we can remember, our equation here is Rg tan theta. Right, it's the same idea here. And remember, this is over there, it's the same, and that there is 45 degrees, just like here, right, 90-degree triangle. So it's going to be opposite over adjacent, so this component divided by that component. You can work it out by first principles, but you end up with this equation anyway. So we've got to make R the subject now, so therefore R is equal to V squared, and we divide it by G tan theta. And now we substitute it in, so it's velocity 550 kilometers. We want it in meters per second, right? So we have to remember that we divide by 3.6. That's going to give us 152.8 meters per second. All right, so we put that in there, 152.8. Take the square of that. Then we have 9.8, and then we go tan 45. So when we do all that, we say that the radius of the turn of the bank is 2,381.7 meters, right? Or 2.4 kilometers. That's a very long turn, but that's what planes will do at that speed and that angle there. Obviously, in reality, we've got a lot of other components that's going to affect that, right? But we're ignoring air resistance, etc., and turbulence. So that's all it for bank tracks. Hope that makes sense. Keep doing your questions, and if you have any problems, make sure you ask any teacher that's studying physics. Okay, see you in the next video.